We're going to we are attempting the pairs assignment. My team is Patrick Tsikayi and Moreblessing Maposa. We're going to demonstrate one ethical working tool, one digital forensic tool. I'm going to start uh, with the ethical working tool, which is masscan. Essentially, what masscan does is to scan open ports on a network or on the internet. So we're going to run a few commands just to demonstrate our understanding of how masscan works. So the first scan that we're going to do is the single port scanning, where we try to scan the network just for one port. So the command for that is scan. We're going to use the IP address 192.168.0.186/32. Then we're going to scan port 25. So we run this. So this is how it performs. As you can see, it's running the scans. Unfortunately, it takes a bit of time. So our recording um, might be very long. So we just going to show the result here. Okay. Fortunately, it was fast. So this is the port that it discovered. So from this, move on to a multiple port scan. The multiple port scan basically we're trying to scan a number of specified ports. So the command for that is masscan. Again, we use the same IP address 186 uh, 2. Okay, so we're going to mention the ports here. Start with the one we've already worked on, 25, 143. As you can see, I've already run these commands before, so it's making suggestions for me. So these are the ports that we're going to try to scan. So yeah, there, as you can see, it is discovered five open ports for 465 to 25, 143, 587, and 110. So we can do a range of scan, maybe a range of maybe between 22 to 25. We can use the same as IP address, um, 192.168.0.186, let's just run maybe port 22 to 25, 22, 25. So there it is. It's scanning. So these are the ports that have been discovered. Yeah. Then maybe we just do another scan where we maybe we attempt to specify the total number of ports that we can scan on a network. This is a functionality that was imported or that was adopted from Nmap. But Mascan, the latest version of Mascan now is it. So in order to do this, the command is mascan 192.168.0.0.116. We just switched at the IP address now is we now scanning using subnet B, which is the IP address is 192.168.0.0. Then we just want to scan maybe top 10 ports. So we feed the number of ports that we want to scan here. So it runs. Yeah, unfortunately, this one takes a bit of time, so we cannot really wait for it to finish because um, maybe we want to compress the video a bit. So we terminate this one. Then we move on to maybe one that takes a lot of resources and time, which is the scanning of all network ports. So what we can do on this one, we're trying to scan all ports in a class B subnet, maybe by stating the red. So ordinarily the mascan scans at a rate of 100 packets per second, but we want to force Mascan to maybe adopt 10,000 or 100,000 packets per second. So in order to do that, just run this code scan 192.168.0.0.6. We want to scan maybe all ports available. So ordinarily, an IP address is about 65,535 open ports that are included in that bracket. So in order to scan all ports, just specify NSP 0 to 5,535. So this is the command, and we're telling it to run at the speed of 10,000 packets per 100,000 packets per second. So yeah, this will take a bit of time because there are quite a number of ports between that. Then lastly, um, we are going to attempt to scan the entire internet for open ports, which is a daunting task, which requires resources, time. The last time I ran this, I think I ran for 8 hours, and the success rate we had discovered around 3,000 open ports, but in terms of progress, it was just around 0.01%. So we'll just run the command for that. Scan 0 0 0 0. Okay, I already have this, so we run this. Unfortunately, we cannot run this during the recording of this video as it takes a lot of time. So basically, this is what is involved in Mascan. It scans open ports. Basically, it works in identifying maybe vulnerabilities in a network or in internet. So this is the ethical working tool that we wanted to present. Now I will hand over to more blessing for the digital forensic tool. I'll just sharing so that more blessing can begin.
Good evening. I'll be taking over from where Patrick left. I'll be presenting on the digital forensic tool. And in this case, we are going to be using the FTK imager. So the FTK imager allows us to access electronic evidence by obtaining forensic images of computer data without changing the original evidence. So I'm going to do maybe just to present on the general interface and maybe just a few steps on how we can practically use the FTK imager tool. So we're just going to start by creating a disk image. So this is the general interface. So we go to File, then we go to Create Disk Image. Then we go to the physical drive. We're going to use the physical drive in order to as our source file. So in this case, we are going to select this drive. That's our drive that we're going to select. Then we're now going to add our destination. So we're going to select on the image type. We're going to use raw. Raw image. It assists us to recover every detail because it does not compress information. Then we're just going to enter our case number here. Let's just say our case number is 0006. Our evidence number 2105, and our unique identifier, let's say we just keep it at FTK image. Then our examiner, then notes image creation. Then we go on next. So now we're going to select our destination image. Remember, at first we selected our source file. So we're going to select drive E, this drive for our destination. All right. So we can create a destination folder. So the next step that we're going to do, it takes a bit of time to load. So we're not going to be demonstrating the whole process. I'll be now presenting on the screenshots of what we managed to come up with as we were doing the lab report. All right. So now you can see the dialog boxes are saying verify images after they are created, then pre-calculate progress check. Then we're going to ignore create directory release, as that will be even more time consuming. So basically this process, as you can see, it needs a bit of time, which is about 12 minutes. So for the sake of progress, we can't really do the other processes practically. So we'll be just presenting them now on a Word document. So after this, we have all done, like selecting the drive and all. Now we were now on. Yes, now our image is created. This is the interface after our image is successfully created. Then we verify our results. Then after we verify our results, we're going to get this window which shows our hash values with confirmation that they match. And if there are any bad sectors, they're also listed. They're also listed on our result. On this screenshot there. Then after that, we'll get an image summary. It means that our image has been created, and it gives us a summary of maybe the case information. How did we acquire it, our case number, our evidence number. This is the good thing about using FTK Imager on digital forensics. Let's say you are investigating a criminal case. It gives you the evidence number, so it becomes easy for you to track on your record. And also the summary also gives us the hash number. It also gives us when we started the acquisition and everything. So that's the summary right there. Then we proceed to now we're viewing the created image in folder together with the created text file. So after we create an image, then they also after creating the image, we also get a text file. A text file, it also has the same information that is on the image summary. So this can then also be converted to other document formats such as Excel. Then these are computed hash numbers. Generally, we just paste them there. Then after creating our image, now we want to capture memory. So memory capturing, it allows us to save the contents of memory, including passwords, before they're erased, because at times people can tamper with data. So it's always good to do memory capturing so that we can get all sufficient information, including passwords in case there are any encrypted files. So this is how we capture our memory. We go to file, then capture memory. I can use another separate window. You see the image was still creating, but this is how we capture memory. File, then you go to the capture memory. Yes. So because of our time, I can't really proceed, but then we just go and we select our destination file. That is if after the creation. So we revert back to our screenshots for progress. So this is our memory dump. Our memory is now captured. It's also a process that takes a bit of time, maybe about 10 minutes. Captured memory, then creating memory ADI. We create an ADI file, which allows us to create an ADI image of the memory contents, which we'll then use to review the contents of our image. Then finally, our memory capture is finished successfully. Then there's the next stage that we can also do as we were practicing with this FTK imager. We were analyzing the image dump. So we just go to file, then add evidence item. So let me just do a demo here to analyze our memory dump. File, then add evidence item, then that same process again. Okay. So now on selecting our dump, the source of evidence, we use the image. Yes. Choose the path of the image dump created. Okay. So this is how we analyze our image dump. So when you attach the image dump to the analysis part, you see an evidence tree with the contents of the image dump file. This data could have been deleted or overwritten. So this is how this tool works. Then the other thing that we explored was we now want to mount the image to our drive. Yes, it's also possible to do that using this imaging tool. So we go to File. Let me just show an interface. So we can't really complete all the processes. You can see like our even our creating image. It's still creating. So that would take the whole presentation waiting for that. So okay. We want to mount to drive. So it's File, then Mount to drive. File, then image mounting. There's also another shortcut that we can use right there on some of the tabs. So we do the same process again. We select destination. So this is what what we had done in the afternoon. You can see now there is physical drive 3. There's G. So G is the one that we had created from our case that we pasted on the screenshot. Case that's the image, that's the drive that was created. So after that, movable disk H on the devices. This is on our PC. This is how the removable disk now it's G. Then basically we have our image on the drive. So now we want okay. So at times we may want to recover information, but from documents that have been encrypted. So FTK Imager can also help us to obtain protected files. So we simply go to File, then go to Protected Files. So we go File, Obtain Protected Files. Then the process continues. We browse to see our destination. So yeah, before that, I wanted to highlight here. You see, there's minimum files for login password recovery. Then there's password recovery and all registry files. So we're going to go with option 2 so that we can recover in case there are any encrypted files and in case there are any other registry files. This one helps us to recover each and every possible lost file. So that's it really. Then we browse. Then we get our case that we want to check for encrypt to obtain if in case there are any encrypted files. So this is a window showing, reading file codes. So after that, then now we want to detect EFS encryption. The same process again. There's the window which is highlighted there, detect EFS encryption. So yeah, it's a bit of a process which also takes a bit of time, but when we ran it, then went on successful. Now, after that, is we like on what we on our image that was created, we noticed that there was no encrypted files. So if there were some encrypted files, they would also have been recovered. So now we go to the last step where we're just exploring what this FTK imager can do in order to enhance digital forensics. We go to exporting files. So it's a simple process: file, export files. Then maybe we can just show that window. So it's file, then export files. Then you go ahead, you select whatever file you want to export. Then so basically that's it. Here we tried to do that the first time. We selected one file without folders. Then the next one we actually selected we actually imported four files, four folders in some files. So basically, this is what the FTK imager can do. So with this digital forensic tool, we can retain file system metadata. We can create of a log of the files copied. It can also provide a case number, evidence number, unique description, examinant, any notes in case of tracking in the future. So basically we can see that this tool, it can also create forensic images from local drives, from and folders and stuff. So I think that's it on the FTK image. So there are so many functions that the FTK image tool can do, but for the sake of progress, we just looked at a few of the functions, and also so that our presentation is not too long. As you can see, it was still creating the image, and now it's on 90%, but it is really a very functional tool. Thank you so much. I will hand over to Patrick to conclude.
Okay, thanks, Mobi. So this was our presentation for the two tools, one for ethical hacking and the other one for the digital forensics. Um, for ethical hacking, we had the masscan, which is a port scanner. For FTK, for digital forensics, we had the FTK imager. So this was our presentation, and thank you very much.